of Lagunglo Senior High School, your teacher for today. And today, I will discuss to you a topic under pre-calculus, conic sections, circles. So let us begin. So this topic is under pre-calculus, conic sections, particularly the circles. So this will be our lesson objectives. A. Senior high school students in pre-calculus are expected to develop the following learning competencies. A1, as a review, we will illustrate the different types of conic sections: parabola, ellipse, circle, hyperbola, and degenerate cases. For this lesson, we will define the circle and we will determine the standard form and general form of the equation of a circle. Okay, let's start with the basics. We will explain the following terms. Undefined terms in geometry, namely the point, the line, and the plane. Also, we will define intersecting lines, parallel lines, perpendicular lines, angle, and a cone as a review. Let us start with the undefined terms in the geometry. Namely, again, the point, the line, and the plane. So a point is represented by a dot in the illustration, while line is a set of points that form a straight line, and a plane is a perfectly flat surface extending infinitely in every direction. Next, the intersecting lines. The intersecting lines are two or more lines that meet at exactly one point, as shown in the illustration. Another is the parallel lines. These are lines that do not intersect, even if they extended infinitely in both directions. Yes, this is perpendicular lines. These are special type of intersecting lines that intersect to form a right angle. Okay, correct. These are angle. It is composed of two rays with a common endpoint, or the vertex. Lastly, a cone. A cone is a solid geometric figure composed of a point called the vertex and a circular base. Okay, as a review, what are conic sections again? Okay, if a plane intersects a double right circular cone, the intersection is a two-dimensional curve of different types. These are called conic sections. So we know that there are four different types of conic sections: the circle, ellipse, parabola, and the hyperbola. So this is how in the lesson 1 they are illustrated. These are the 4 conic sections. Lesson number 1, you have learned the 3 degenerate cases. These are point, line, and intersecting line. Okay, let's formally start with circles. So by definition, a circle is the set of all points equidistant to a fixed point. That is the radius. And our fixed point represents the center. So, equation of a circle. Okay, given the illustration, let us assume that we do not know the actual coordinates of the center. So, in a circle, the center can be represented by coordinates h and k. And the distance between those points in the illustration with point x and y is the radius. Okay, the standard form of the equation of a circle. Okay, the standard form of the equation of a circle whose center is at the origin with radius r is x squared plus y squared is equal to r squared. That is in the case in which the center is at the origin. For any circle, the center have coordinates h and k with radius r. The standard form of the equation is x minus h squared plus y minus k squared is equal to r squared. Again, let us remember, if the circle has center at the origin, we are to consider x squared plus y squared is equal to r squared. And in the other hand, if it has the coordinate of h and k, its equation would be x minus h squared plus y minus k squared is equal to r squared. Okay, how about the general form of the equation of a circle? Okay, the general form of the equation of a circle is ax squared plus ay squared plus cx plus dy plus e is equal to 0. And that a could not be equal to 0. The standard form of the equation of a circle examples. So give the standard form of the equation of the circle described in each item below. So we will try to solve each one of them, starting with number 1. So for number 1, our center has coordinates 0 and 0, and our r is equal to a. So remember, the standard form of the equation of a circle whose center is at the origin with radius r is, so if you try to look at example number 1, its center is 0 and 0, which it is in the origin. So we write the standard form of the equation of a circle for number 1 in the form x squared plus y squared is equal to r squared. So our answer would be x squared plus y squared is equal to 8 squared. Okay, correct. Okay, for number 2, we have the given. Our center is at the origin and our r is equal to 5 over 3. So take note that number 2 has the same case with number 1, in which its center is at the origin. So we write our answer be x squared plus y squared is equal to 5 over 3 squared. Do we have the same answer? Okay, very good. So let us proceed with number 3. Given for number 3 is our C has a coordinate of 4 and 1 and containing radius equal to 4. So remember, for any circle whose center have coordinates h and k with radius r, the standard form of its equation is this one: x minus h squared plus y minus k squared is equal to r squared. So what are we going to do? We will just replace our coordinates to h and k. So I'll give you 10 seconds to solve. So let us proceed to our answers and let's try to check whether we had the same answers. So our answer would be x minus 4 squared plus y minus 1 squared is equal to 4 squared. Okay, very good. Okay, with number 4. For number 4, we have the given. Our center has coordinates -3 and -5 and containing our radius equal to 3. Okay, I will give you 30 seconds to solve this given. Your time starts now. Okay, so let's try to check our answers. So let's see if we have the same answer. Our answer would be, okay, x plus 3 squared plus y plus 5 squared is equal to 3. Take note that your original equation, your h here is negative and your k here is also negative. So if we will replace our value for -3, it will become +3. If we will replace our value -5, it will become +5, correct? From general equation to standard form. So given x squared plus y squared plus 6x plus 16y plus 48 is equal to 0. So this is a step-by-step process. So we will group the terms based on the variables. So we have now x squared plus 6x plus y squared plus 16y is equal to 48. So take note that we have grouped our x and our y's. So next, we will complete the square to make each group of terms a perfect square trinomial and add the constants of the perfect square trinomials to the right side. I believe you have undergone this topic during your grade 11 general mathematics. So we will get the half of our b and we will square it. So half of 6 is 3 and 3 squared is 9. Half of 16 is 2 and 8 squared is 64. So our new equation would be x squared plus 6x plus 9 squared plus y squared plus 16y plus 64, in which both of them is a perfect square trinomial, is equal to, so we add now the constant, negative 48 plus 9 plus 64. So our new standard equation would be, so the perfect square binomial for x squared plus 6x plus 9 is equal to x plus 3 squared, and for y squared plus 16y plus 64 is y plus 8 squared is equal to 25. So this is now our standard equation of circle. Let's try another examples. So number 1, our given is x squared plus y squared minus 6x minus 7 is equal to 0, and number 2, x squared plus y squared minus 14x plus 2y is equal to negative 14. So let us try to answer. Okay, we will try to answer all together. Example number 1. I'd like you to get a paper and a ball pen and let us solve together. So what is the first step? We will group our equation according to variables. We will group x and we will group y. So in this case, we'll have x squared minus 6x plus y squared is equal to, correct, positive 7. So get the perfect square trinomial of this one. So we divide 6 with 2 is equal to 3 and we will square it. So the answer is 9. So we will have here x squared minus 6x plus 9. Okay, correct. In here, we will have y squared plus 0y plus 0 is equal to 7 plus 9. So, what is the perfect square trinomial for 6x minus, x squared minus 6x plus 9? Okay, very good. X minus b squared. For our y, that is y plus 0 squared is equal to 16. Okay, very good. So, our new equation for our standard form given the general equation is x minus 3 squared plus y plus 0 squared is equal to 16. So, do you have the same answers with you? Okay, if you have, so, very good. We will now solve another example. And this time, I'd like you to solve this example. I will give you 30 seconds to answer. Equation number 2. This time, I'd like you to solve it. I'd like to give you 30 seconds to solve this equation. Your 30 seconds starts now. Okay, I will try to solve here and you will verify whether you have got the correct answer. Okay, so first we will group equation. So I'm sorry with my penmanship since I am new to using this one plus y squared plus 2y is equal to negative 14. Okay, very good. Okay, next step. We'll get the perfect square trinomial for x squared minus 14x. Okay, we will divide 14 by 2. What is the answer? 7. And we will square 7. The answer is 49. Okay, very good. Give time to write our equation. I'm sorry. That is 49. And for our y, we will divide our 2. Divided by 2 is 1. Squaring it by 1, we will have the answer of 1. So that is now our perfect square trinomial. Remember, whatever you add here, we added also here. So we will add here plus 49. I'm sorry. We will add 49 and 1. So, what we have is a perfect square binomial for this. Correct. X minus 7 square plus this one y plus 1 square and negative 14 plus 49 plus 1 is 36. This is now our standard equation of a circle. Okay, we will now transform an equation into a standard form into a general form. So say example number 1, x minus 2 squared plus y plus 3 squared is equal to 11. So what are we going to do? We will expand the binomial. So you will multiply x minus 2 and x minus 2, and y plus 3 multiplied to itself. Product now is x minus 2 minus 4x plus 4 and y squared plus 6y plus 9 is equal to 11. Afterwards, we will now simplify. So we will write x squared plus y squared minus 4x plus 6y plus 4 plus 9, and with the additive property of equality, minus 11 is equal to 0. So if you will try to work out our equation, our answer would be x squared plus y squared minus 4x plus 6y plus 2 is equal to 0. This is now our answer. So observe that this is now in the general form. So, with that, I will leave you an assignment. Okay, this will be your assignment. Copy your assignment. I hope that you have get something from what I have discussed this afternoon. And I know that you can now define a circle and transform equation to general form to a standard form and vice versa. So with that, thank you and God bless.